Dear friends, today we have a special episode of Super Tony's Adventures. Enjoy! Hello dear friends, and a big welcome to our subscribers. Today, we are gonna take a look at something different, Tony. We are gonna explore the space. So, let's go really quick to our secret base. Anthony, suit up. In today's experiment, we are gonna find out what is at the end of the universe. Tony, I see you're ready, so let's get going. But for this long trip, we need an incredibly super fast spaceship. Sadly, the ships that exist today are no use to us. For example, the Voyager 1, which is the absolute record holder among man-made spaceships, moves at a speed of merely 62,000 kilometers per hour. At that speed, we would be traveling until the end of times. So, we are gonna use a secret invention of ours, a teleport. So Tony, are you ready? 1, 2, 3, let's go! So, here we are, at the end of the universe. According to one theory, there is no time or space here, and we are surrounded by nothing. It sounds like gibberish, yeah, but there's another similar place. The center of the universe at the beginning of the time. So instead of flying to the end of the universe, we are now at the center of it, at the beginning of everything. Tony, hey, what happened? Holy, now we know how the Big Bang happened. But let's take a look at another, more simple theory. It goes like this. It is impossible to reach the end of the universe. Why, you ask? Because we are all part of the universe, which means that if we reach the end of the universe, we are simply expanding its limits. Thus, we are not longer at the end of the universe. So, long story short, it's simply impossible to reach the end of the universe. And for dessert, let's take a look at a theory that states that our world is a virtual reality. In other words, that our universe is just a bunch of digital information. So if we go beyond the boundaries of our universe, then we will find ourselves in another higher world, the world of our creators. Tony, for example, will end up in the world surrounding you right now, but nobody knows what we would find if we reach the end of the universe. And maybe you, the person watching the show, would be the future researcher of the furthest places of our limitless universe. You would be the person telling us what's beyond our universe. Tony, put on your spacesuit, hop on the spaceship, and let's go to space. Today we are gonna take a look at one of the most mysterious and unknown objects in the universe, a black hole. We're gonna learn what is a black hole, and we're gonna see if it can take you to any point in time and space, or if it's only death and nothing more. And you'll be right in the middle of it. Let's start. So we're almost there. Do you see the black hole? What do you mean no? Is that place where there's nothing else? Yeah, that's right. The thing is that black holes are massive objects that absorb light instead of reflecting it, so seeing one is almost impossible. On top of that, their gravity is so strong that even light distorts under its influence. So, around a black hole, the universe seems blurred and distorted. By the way, the term black hole is not quite right. It is more a sphere that absorbs everything that gets close enough to it. So, how these cosmic vacuum cleaners came to be? Imagine a star like our sun, but several times bigger. At the end of its life, this star will shrink, getting smaller and smaller, while its mass remains the same. In this case, the star's density increases along with its gravity. When its size reaches its minimum and its density is at the highest level, the star collapses and a black hole appears. But keep in mind that not all stars can become black holes. A small star like our sun will turn into a neutron star, which is a bright white dwarf that soon will fade. Keep in mind that in space, soon can mean millions of years, while a small star is thousands of times bigger than our planet. For example, in the middle of our galaxy, the Milky Way, there is a huge black hole known as Sagittarius A star, whose mass is 4 million times bigger than that of our sun. And it's located at a distance of 26,000 light-years away from us. This means that at the speed of light, which is 300,000 kilometers per second, we'll need 26,000 years to get there. 26,000 years, Carl. But we live in an animated world, so we got here in just one instance. So let's get out from our spaceship and get close to the hole to see what's inside it. First, we have to pass the event horizon, which is something like the outer boundary of a black hole. Once we pass it, there's no way back, because the gravity is so strong that nothing in the world can take you back. Tony doesn't feel anything weird, but if he looks back, he will see the whole history of our universe, from the Big Bang to its end. With each second, Tony will move towards the center of the black hole faster and faster. There he will meet singularity, which is the center of the black hole, and the closer he gets, the worse he feels. The gravity becomes irregular and starts to act differently in different parts of the body. So, your organism will compress and stretch at the same time. This is known as spaghettification. Basically, Tony will turn into one long and thick spaghetti. It doesn't sound very pleasant, but it gets even worse. Tony's body will divide into subatomic particles, which means that it will break into little pieces impossible to see. So, from the outside, it looks like the body disintegrated into nothingness. Nevertheless, friends, there is another theory. Some physicists state that the gravitation inside the black hole is so strong that it distorts space and time, causing the appearance of a wormhole. This is like a tunnel that allows you to travel anywhere in the universe. So, if a spaceship manages to withstand the effects of gravity and reach the singularity in one piece, it could enter the wormhole. Then it can travel to the past, the future, other galaxies, other universes, or even other dimensions. We must say that Stephen Hawking, the most famous physicist and cosmologist of our time, didn't believe in this theory and stated that the only thing you'll find in the center of a black hole is total annihilation. But if wormholes are real and another civilization learns to control them, then we should expect a visit from another galaxy, or maybe from another time. Tony, pack your bags. We're going to outer space. More precisely, to the International Space Station. Yeah, we're gonna experience zero gravity, enjoy an amazing view out the window, and get close to the stars and far away from our earthly problems. Or is space a harsh place where you have to fight to survive? We're about to find out, and we're gonna tell you all about it. Let's start. Here we are, in the Earth's orbit, and the International Space Station is right here. We are now about 400 kilometers from the surface of our home planet. By the way, a widespread belief is that there is no gravity here. Well, friends, you shouldn't sleep during physics class. There is gravity on the ISS, and it is only 10% lower than on Earth. However, despite this, astronauts are constantly in a state of weightlessness. This occurs because the station is constantly moving along the Earth's trajectory at a speed of 7 kilometers per second. Basically, it is in a state of freefall and weightlessness. It's like a falling airplane. By the way, there are even special rides that create a similar effect. A plane rises to a great height and then sharply falls. While inside, you are also in a state of freefall, but the hull protects you from air resistance, allowing you to reach a state of weightlessness. But let's go back to the ISS. It is weightlessness that causes the biggest problems for astronauts. Let's take a look at some of them. The first and most important is muscle atrophy. On Earth, we are constantly struggling with gravity. Our muscles and skeleton have been experiencing it since we were babies. But in weightlessness, the musculoskeletal system loses all resistance. So muscles weaken and bones suffer from calcium depletion. This is why astronauts must devote at least 2 hours of their daily routine to physical activity on special simulators. However, this isn't enough, and as a result, when astronauts go back to Earth, they need to readapt. Their legs, arms, and head are so accustomed to the lack of gravity that they feel very heavy, and it is as if all the strength has been drained from the body. Another problem with zero gravity is related to the different life processes within the body, because humans are supposed to live on Earth, not in space. The human circulatory system is designed so that blood flows to the lower part of the body under the force of gravity, and then the heart pumps it back up. In weightlessness, this does not work. As a result, the legs do not receive enough blood, while the head is flooded with it. Special compression tourniquets help to solve this problem, ensuring proper blood supply. Now let's talk about food. We all have heard about tubed foods and even saw it in different space museums and movies. However, this is a thing from the past. Now on the ISS, people eat regular but compactly packaged food. However, table manners in space are much stricter than down here. In space, any lost crumbs can get into the airways, while water can damage the complex equipment. So anything that flies away should be caught immediately. By the way, special cargo ships regularly come to the ISS to deliver fresh and healthy food to the astronauts. Now let's see how astronauts sleep. The problem is that the ISS circles the Earth in 92 minutes, so you can't go to bed at sunset and wake up at sunrise. Over the course of an Earth day, astronauts can see many sunrises and sunsets. Therefore, there is a rule that after every 16 sunrises and sunsets, the windows close and everyone on the station goes to bed. Well, it's not exactly a bed, because everything is different in weightlessness. There is nothing to push your body against the mattress, so you are basically in the same position as you were all day. This is confusing. Only habit and special fastened sleeping bags keep you from flying around the station while you sleep. So there you go, Tony. It turns out that it's not so great to live among the stars. Of course, scientists keep working and improving the life of astronauts, but only those who are well prepared, both morally and physically, can go into space. So we should start training. Elon Musk is promising that soon we will begin to populate Mars on a mass scale, so we need to be ready for that. Thankfully, you and I live in an imaginary world and we can go to Mars right now. Today we're going to check the problems that the future colonizers of Mars will have to face. Let's go! And here we are. Some good news first. There are more than 5 million cubic kilometers of ice at the poles of the red planet. If we were to melt it, it would be enough to cover the whole surface of Mars. But we are not going to do that. We're going to need this water for something else. The thing is that Mars's atmosphere is very thin and is made mostly of carbon dioxide. But we can use electricity to break up water into hydrogen and oxygen, which we really need for our new airtight Martian house. Now let's talk food. Sending cows, pigs, or other animals to Mars is not easy. Therefore, we're gonna have to go vegan for a while. But there is a problem. Plants need sunlight, and Mars is 1.5 times further from the sun than the Earth, and so it receives less solar light. But thanks to a simulated Mars Analog Research Station in Canada, we now know that the light will be enough to grow different plants, such as tomatoes and carrots. But there's another problem with our little garden. The excess of oxygen, it's a fire hazard, so we need to dilute the air with a neutral gas. On Earth, this is naturally done by nitrogen, but this element is almost non-existent on Mars. So, bringing nitrogen from Earth will make flying to the red planet even more expensive. Moreover, machinery fails with time, so we are going to need a ton of replacement parts to keep everything in our colony working. Don't forget that Mars and the Earth orbit around the Sun and sometimes find themselves very far away from each other. But once every 26 months, they come relatively close to each other, with only 55 million kilometers between them. And there are other problems. Gravity is weaker on Mars than on Earth. At first, our astronauts would feel like Supermen, flying around and doing heavy lifting. But over time, our bones and muscles will grow weaker because of the lack of gravity. And another problem is cosmic radiation. Earth's magnetic field stops 99% of the harmful radiation, but there's no such field on Mars. Theoretically, all these problems can be solved, and scientists have more than 10 years to find the right answers. Hopefully, they will manage to solve everything and send Earth's first mission to Mars successfully. The future is here, dear friends. We are going to witness humanity conquering the space. But for now, we have to wait. So tell us what you think about Mars missions and the problems they could encounter there. The best comments will be featured in the next video. See you soon in a new episode of Super Tony. Don't worry, we'll be back on Earth by then. Bye-bye.